Hello students, welcome you all for the second class of chapter number 6, Heat and Energy. What did we see in the last class? In the last class we have seen what you mean by heat, what you mean by temperature, right? And what are its SI units, CGS unit, conversions, and also we have seen the difference between what you mean by heat and temperature, and what are the temperature, how to convert Kelvin to Celsius, Celsius to Fahrenheit. All these things we have been seeing. So continuation part of the chapter, we have first what you mean by thermal expansion. So what do you mean by thermal expansion? See, thermal is nothing but heat. That the heat, we are giving the heat, it is nothing but what you mean by thermal. Thermal is a word which is used instead of heat energy. On causing the heat energy, we get what you mean by thermal expansion. Expansion means you know that how it is getting expanded. Let us see what happens. Look at it. All substance on the earth, that is electricity, solid or liquid or gas, all the three states of matter expand on heating. Obviously, expand on heating and contract on cooling. Understand? So this is the concept of what you mean by thermal expansion. All the substances on the earth, whether all the three states of matter, solid, liquid, gas, you all know this. We have studied in the physics also, we have studied in chemistry also, right? So all substances that is solid, liquid, gas expand on heating, contract on cooling. Now let us see in detail. So how do we define thermal expansion? How do we define thermal expansion? Means the expansion of the substance on heating. Look at here, heating is must because we are speaking of thermal expansion on passing the heat. The expansion of a substance on heating is called thermal expansion of the substance. Understand? Just this much only. An expansion of a substance on heating that substance is getting expanded, that itself is called a thermal expansion of the substance. Now let us see how does thermal expansion happens in solid and in liquid and gas. Is they one and the same or what? We will just see now. Look at here in solid. You know that solid will be considered, right? This is solid. Obviously, you know that molecules are arranged in this way. Molecules are tightly packed in the case of solids. This is what we have been liquid. Hence, we call solid to be rigid body. We call it as a rigid body. This is how the molecules have been there. A solid has a definite shape, obviously. It has a definite shape. So, when solid is heated, it expands in all directions. Understand? Look at it. Think that you are heating it. When you keep on heating, you might have seen that how they bend the iron. By keep on heating, it turns red in color, then they give a definite shape. Understand? So, on heating the solid, what happens? It expands in all the directions equally. It expands in all the directions. It expands in all the directions. Understand? Okay, first let us see. Length, increase in length is called linear expansion. Increase in the length. See, linear means you know straight. The increase in length, the increase after heating, if the length of the after heating, if the length of the solid is increase in length, we call as what we mean by linear expansion. What we mean by linear expansion. Area, increase in area is called superficial expansion. Area means this is the area, right? From here to here. Even this will increase. Now, for example, I can. This is the solid. Okay. This solid I keep on heating. There was first linear expansion. This much has become this much. Understand? Now area. This was the area. Now see, it has become expansion of the area means you should get. And even what next? Volume. Whatever the volume of that increases is called cubical expansion, or even cubical is also called volume. Okay. That is volume expansion. All the three things will be happening in the case of a solid. A thermal expansion on solid will lead to linear expansion, superficial expansion, cubical expansion. Why? because solid has a definite shape. Understand? All the molecules are tightly packed. So when solid is heated, remember when the solid is heated, it is expanded in all directions. In all directions means length, its area, its volume. So increase in length is called what? It is called linear expansion. Increase in area is called superficial expansion. Increase in volume is called cubical expansion. Understand? This is very, very important for your this. See, the definition is important. First remember, all the substance of nothing. There are few exemptions, but when we say that almost all substances, that is solid, liquid, gas, expand on heating and contract on cooling. There are some substances which expand on cooling, contract on heating. That is called anomalous expansion of water. We will be studying in the next after this. Next, we have what you mean by liquid and gases. What is the liquid and gases? They do not have a definite shape. Obviously, you know that what you mean by gas or liquid takes the shape of the container. You might have studied that. And for example, in your, you might have this diagram telling that molecules are not closely packed as the case of solid in the liquid or gaseous. In the liquid is better. Gas, it has a random motion. All the molecules will be having a random motion, no tightly packed. So they do not have a definite shape, so they have only the cubical expansion. In the case of liquid and gas, there is no linear and superficial expansion because they don't have a definite length in the sense they don't have a definite size and shape, right? So there will be no linear expansion and superficial expansion. Only there will be a volume expansion, that is cubical expansion. This is the main difference between the thermal expansion between solid and liquid and gas. So now on heating, when we are heating, gases expand much more than the liquids. Why? See now solid, liquid, gas when you consider. Think this is gas. We have liquid bit close than the top gaseous. We have solid, liquid and gas. So we have molecules slightly packed. So on heating, gases expand much more than the liquids. The expansion is more when you are heating it. Which expansion? Expansion in volume, that is cubical expansion, is more in the case of gas than liquids. When you compare liquid and solid, liquid is having more cubical expansion, that is volume expansion. So this is very, very important. So liquid expand much more than the solids. And as I told you before, not all the substances, maximum 99% will expand on heating and contract on cooling. But there are some which contract on heating, expand on cooling. So what are those? We will study now in the concept of anomalous expansion or anomalous expansion. In that mainly we will take us what we mean by water. That is what happens from 0 degree to 4 degrees Celsius to 0 degree. From 4 to 0, what happens? How the water gets cooled not in anomalous expansion. Next, as I told you, now we have the concept of what you mean by anomalous expansion of water. What do you mean by anomalous expansion? Just now I told you, all the substances on the planet, that is 99% of them, expand on heating, contract on cooling, right? But see what happens in anomalous expansion. Some substances such as water, for example, I have taken 2, in your textbook they have given 3, even they have given silica, okay? On water, that is from 0 degrees Celsius to 4 degrees Celsius, and silver iodide from 80 degrees Celsius to 141 degrees Celsius, contract on heating. Look at here. All the other substances expand on heating, contract on cooling, but these substances only at certain temperature, remember, contract on heating and expand on cooling. Understand? So this is what the expansion of a substance on cooling, in a certain range of temperature is anomalous expansion of that substance. they ask you to define anomalous expansion. You need to write this definition. Anomalous expansion of substance. Substance means it may become water also, it may become silver hydride also. But mention the temperature range. Understand? Now what? The expansion of a substance on cooling and in a certain range of temperature is anomalous expansion of water. The substance are expanding on cooling. That is what the concept of anomalous expansion. So how do we define the anomalous expansion? Here, anomalous expansion of water I have defined. How do we define the expansion of water when it is cooled from 4 degrees Celsius to 0 degrees Celsius is known as anomalous expansion of water. First of all, anomalous expansion is what? The substance get expanded on cooling. What is the range? We are cooling water from when the water is 4 degrees Celsius. When we cool it to become 0 degrees Celsius, understand? This is known as what we mean by anomalous expansion of water. What is the use of anomalous expansion of water? We will see in the later part of the chapter. But you will understand the only difference between the normal thing and normal. Usually substances expand on heating, contract on cooling. But in anomalous expansion, some substances at certain temperature, for example, water from 0 to 4, silver hydride from 80 to 140. What they do in that temperature? They do behave in an opposite way. That is, expand on cooling, contract on heating. So this is what the concept of what we mean by anomalous expansion of a substance. In that anomalous expansion of water is 0 to 4 degree to 0 degree Celsius. Water is cooled. This is known as anomalous expansion of water. This is the definition, very important. Next, I will plot a graph and see. Look here. In x-axis, I have taken temperature. In the y-axis, I have taken volume. Understand? So first, what is the relationship between density and volume? Do you remember? So density is denoted with the letter rho. Density is equals to mass by volume. Right? If volume increases, density increases. If volume increases, density decreases. They both are having inversely proportional to each other. See, density is denoted with the letter rho. Rho, right? In some textbook they will give sometimes D as also density. Okay, but standard notation is rho. Okay. Now, the volume of water first decreases on heating. Understand? The volume of water, first what happens to volume of water? It decreases on heating from 0 to 4 degrees Celsius. Here I have taken 1 gram of water. Okay. I have taken 1 gram of water. Okay. What happens? It keep on decreasing till 4 degrees Celsius. Look here. Decreases on heating 0 to 4 degree and then increases on further heating from 4 to 10 degree. When you are heating the water, what happens? The volume of water first decreases actually. Whatever the volume of water it is having, it is getting decreases from where to where? 0 degrees Celsius to 4 degrees Celsius. On further keep on heating, after the 4 degrees Celsius, it keeps on increasing until 10 degrees Celsius. That is what the anomalous concept of water. The volume of water first decreases on heating from 0 to 4 degrees Celsius and then increases on further heating from 4 to 10 degrees Celsius. The volume of water is their minimum. Where the minimum water at what temperature is 4 degrees Celsius. Remember, this is very important question. They ask. At what temperature is the volume of water is minimum? At 4 degrees Celsius. Now there is given one more graph to plot in your textbook. That is, already we have plotted temperature versus volume. Now I will be plotting temperature versus density. Okay, density in kg per meter. So I will take 1 year, 0.9. 0.91 like that. I will be plotting temperature at 0, 1, 2, 3, 4, 5 to 10 in feet. So now already See how the volume is doing. Volume is first decreasing, then keep on increasing. Right? On heating it from 0 to 4 degree, what is happening? Volume is decreasing. On after we continue heating from 4 degree, volume is increasing. But what about density? Obviously, density is inversely proportional to volume. Means here where the volume decreases, density increases, and where the volume increases, density decreases. That is what the concept. See here, first when you take 1 gram from 0 to 4 degree, density increases. What it is? You have to take 3 here. Till 4 degree Celsius. See, I am not plotting it neatly. When you plot, you will get it. Till from 0 to 4 degree, density is increasing upper side. Then what happens after that? When volume is increasing, density is decreasing. Understand? So this is what the concept of these two graphs are very important for your examination point of view. Understand? So please plot this, and if any other doubts regarding anomalous expansion or something, we will see in our online classes too. Understand? So I hope you have understood the concept of today's what you mean by thermal expansion, and also what you mean by anomalous expansion of substances and anomalous expansion of water, and the graphs, temperature versus volume graph versus temperature versus density. Density and volume are inversely proportional to each other. When volume decreases, density increases. 0 to 4, here it is decreasing, here it is increasing. 4 to 10, it is decreasing, here it is increasing, here it is decreasing. So that is what the concept we need to know. And we have two uses of what is the consequences. Where do we use this anomalous expansion of water? Why the anomalous expansion of water is helpful to something? We can see.